Hello everyone, welcome to lecture 4 of our course Basic to Advanced Level Linear Analysis. In this our topic is methods to find LUB or supremum and GLB or infimum. हमारा जो फुल कोर्स है यहाँ पे 4 पार्ट्स पे डिवाइड है, पार्ट 1, पार्ट 2, पार्ट 3 and part 4. Full syllabus of the course are: for part 1 is set theory, real number system, sequence and series, continuity and differentiability. part 2 में होगा Riemann integral, topology of real numbers. part 3 में होगा countable and uncountable set and part 4 में होगा sequence series of function and function of bounded variation. यहाँ पे पार्ट 1 एंड पार्ट 2 में जैम और नेट के लिए है एंड पार्ट 3 एंड पार्ट 4 सिर्फ CSR नेट के लिए है. नाउ वी आर इन पार्ट 1. हियर फंक्शन, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी कवर होगा. सो इन द लास्ट लेक्चर विच वाज लेक्चर 3 where we have discussed that Archimedean property and its application. उसके बाद हम थ्योरम देखे थे एक, उसके बाद हम 2-3 प्रॉब्लम देखे थे एंड आखिर में देखे थे नेस्टेड इंटरवल थ्योरम. आप प्लेलिस्ट पे जाके ये सारी के सारी वीडियोस चेक कर सकते हो बेटर अंडरस्टैंडिंग के लिए. नाउ टुडे लेक्चर 4 पे जो टॉपिक्स यहाँ पे कवर होगा वो है, फर्स्ट हम 2-3 प्रॉपर्टीज देखेंगे जहाँ पे लास्ट प्रॉपर्टी ये होगा. उसके बाद 3-4 प्रॉब्लम हम सॉल्व करेंगे, हाउ टू फाइंड सुप्रीमम एंड इन्फिमम. ये सारे सेट के लिए हम सुप्रीमम एंड इन्फिमम और LUB और GLB फाइंड करेंगे. सो जो कुछ हम इस लेक्चर पे डिस्कस करेंगे उसका जो PDF आप हमारे वेबसाइट से www.mathnospedia.in से डाउनलोड कर सकते हो. लिंक डिस्क्रिप्शन में मिल जाएगा. आप लोग हमारा व्हाट्सएप ग्रुप भी ज्वाइन कर सकते हो फॉर नोट्स एंड रेगुलर अपडेट्स. एंड इफ़ यू हैव एनी डाउट्स यू कैन मेल मी at mail@mathnospedia.in. I will try to solve your answer. So let's start today's lecture. So important properties में जो पहला, let us consider S B subsets of R. Then हमारा जो पहला प्रॉपर्टी होगा वो है, if A subset of B then supremum of A is subset of supremum of B and infimum of B is subset of infimum of A. मतलब अगर सुप्रीमम के केस में डायरेक्ट रिलेशन होता है एंड इन्फिमम के केस में इनवर्स रिलेशन, B आगे आ जाता है एंड A लास्ट में चला जाता है. उसके बाद जो प्रॉपर्टी 2 है वो है सुप्रीमम ऑफ माइनस A is nothing but minus of infimum A and infimum of A is equal to minus of supremum of A. The third property is supremum of A plus B is equal to supremum of A plus supremum of B. Now important remark is that if A minus B then supremum of A minus B is equal to supremum of A minus of infimum of B होगा. ठीक है, let us prove this remark. Observe that we can write supremum of A minus B is equal to supremum of A plus minus B. माइनस B को हम ऐसे लिख सकते हैं प्लस ऑफ माइनस B. Then we can write as you already know supremum of a plus b is equal to supremum of a plus supremum of b. So we can write this supremum of a plus supremum of b minus b. Using property 3, we can write this. Next, using property 2, we can write supremum of minus b is equal to minus inf b. That's why this gives supremum of a minus b is equal to sup a minus inf b. Similarly, remark 2 is infimum of a minus b is equal to infimum of a minus supremum of b. So these are the all important properties if you have to remember it. Next, let us solve a question. The question 1 is find the supremum and infimum of that set S is equal to m by n such that m less than 2n and where n, m belongs to natural number set n. Observe that here m by n are all greater than 0 because m greater than 0, n greater than 0, therefore m by n greater than 0. Therefore, we have infimum of S is equal to 0 because of all the element of S are all greater than 0. So the lowest value must be 0, which is the greatest lower bound of all the elements. That's why infimum of S is equal to 0. Now observe that as m less than 2n, we can write m by n less than 2, and that's why all the elements of the set are less than 2. So that's why supremum will be is equal to 2. Okay. Next, let us consider the question 2, which asks that find the sup and inf of the set S is equal to m plus n by mn where n comma m belongs to n. How can we find that? Observe that we can write m plus n by mn is equal to m by mn plus n by mn, which is 1 by n plus 1 by m. Then consider a is equal to 1 by n and b is equal to 1 by m, the sets. Okay. Then we can write supremum of a is equal to 1 and infimum of a is equal to 0. Why so that? Because observe that all the elements of a are 1, 1 by 2, 1 by 3, 1 by 4. So 1 is the largest value and all are decreasing and all the value also greater than 0. So every element of the set A and also B are similar sets. So every element of A is greater than 0 and less than 1. So 0 is the lowest value and 1 is the greatest value. That's why supremum of A is equal to 1 and infimum of A is equal to 0. Similarly, we can say supremum of B is equal to 1 and infimum of B is equal to 0. Then supremum of S with the given set we can write as like by property 3 supremum of A plus supremum of B, and this gives 1 plus 1 is equal to 2. So supremum of given set S is 2 and infimum of S is equal to infimum of A plus infimum of B, that will give you 0 plus 0 is equal to 0. So that's why supremum of S is equal to 2 and infimum of S is equal to 0. Okay. Now the next question is very important example. Find the supremum of that set S is equal to 1 by n minus 1 by m such that n comma m belongs to n. Okay, how can we find supremum? Observe that if we take A is equal to 1 by n and B is equal to 1 by m set, then by similar method of question 2, we can write supremum of A is equal to 1, infimum of A is equal to 0, and supremum of B is equal to 1, infimum of B is equal to 0. Then observe that we can write the given set supremum is equal to supremum of A minus B. A and B को अगर माइनस ले लेते हो तो S मिल जाएगा, इसीलिए हम गिवन सेट को ऐसे लिख सकते हैं supremum of A minus B. Then using remark 1 of property 3, we can write this supremum of A minus infimum of B. So by putting this supremum of A and infimum of B, we get 1 minus 0, which is 1. So the supremum of the given set S is nothing but 1. Okay. Then infimum of S, we can write infimum of A minus B, similar like supremum of A minus B. Then by remark 2, we can write infimum of A minus supremum of B, and putting this value, we get 0 minus 1 is equal to minus 1. So we get supremum of that set S is equal to 1 and infimum of that set S is equal to minus 1. This is our answer. Okay. Now consider question number 4. This is the last example of today's lecture. We have to find LUB and GLB of the set S, which is of the type of x plus 1 by x, where x belongs to R and x greater than 0. So every element of this set is of the type x plus 1 by x. Now here we will use a known property inequality, which is known as AM greater equal to GM. Okay, that means arithmetic mean is greater equal to GM. If you take two real number x and 1 by x, then its arithmetic mean will be x plus 1 by x by 2, and its geometric mean will be square root of that two number 1 by x into 1 by x, which is square root of 1 is equal to 1. So using this AM greater equal to GM, we have this x plus 1 by x by 2 greater equal to square root of x into 1 by x. Then by simplifying, we get x plus 1 by x greater equal to 2. Okay. So every element of S are greater equal to 2. So 2 is the lowest value of all the element. That's why we can say GLB of S is equal to 2. Now observe that as x tends to infinity, that is for large value of x, 1 by x tends to 0 and x tends to infinity. So as a whole, the sum of x plus 1 by x will go to infinity. That's why there exists no upper bound of that set S. That's why LUB does not exist. We know that if upper bound does not exist, then LUB also does not exist, and hence we can say that LUB of that set s is equal to infinity. That's why we conclude that a GLB of s is equal to 2 and LUB of s is equal to infinity. That's it for now today. We have to stop now. In the next lecture, we will cover sequence of real number. We'll start the lesson of sequence and series. The very introduction video will be the next lecture, and from here the real course will start. From this section, a lot of questions are asked in the competitive exams. So we will see you in the next video. Till then, goodbye.